Welcome back. This is part 2 of section 1.2. This is where we're going to be talking about circles, and this is on page 3 in your note packet. As you may remember from geometry, the standard equation of a circle, the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. And that the center is located at hk and the radius is r. So for problem number 11, we're identifying where the center is and what the radius is. Keep in mind that for these, we have to keep in mind that it's x minus h. So really what you're doing is it's x minus 3 equals 0. So you get x equals 3. You're going to get to the point where you get comfortable that you're subtracting h. So that's why the 3 is a positive. And then y minus 2 equals 0. So y equals 2. But this is a technique so that you always know what your sign is going to be. You can just set each of the factors equal to 0. So the center is at 3, 2. And the radius squared is 36, not just the radius. So to find the radius, we take the square root of both sides, r equals. Now, if you think when we solve by squares, we get to our two solutions, plus or minus 6. Now, the radius is the distance from the center to the side of the circle. And distance is always a positive number, so we don't include the plus or minus. The radius is just a positive 6. And there's the center and the radius for that equation. On the next page, find the equation of a circle with a center of negative 2, 5. So that's our values for h, k, and the radius is 4, so that's r. So our equation of a circle, x minus h squared plus y minus k squared equals r squared. Be careful of your signs. It's x minus a negative 2 squared plus y minus 5 squared equals 4 squared. So we're just going to clean up the signs. Subtracting a negative, we're adding, so it's x plus 2 squared plus the quantity of y minus 5 squared, and that equals 4 squared, which is 16. And that's how you would write the equation of the circle. Now, in problem number 13, we have a point on the circle at 3, 4, and the center, that's our hk, at negative 1, 2. What we don't know is the radius. We can find the radius by using our equation of a circle, because if it's on the circle like this point, that's a value for x and a value for y. So x minus h squared plus y minus k squared equals r squared. So it's going to be, instead of writing x, 3 minus negative 1 squared, 4 minus 2 squared equals r squared. So you get 4 squared plus 2 squared equals r squared. 16 plus 4 equals r squared, so 20 equals r squared. Now, if we want to find the radius, that's when we take the square roots, we'd get the radius equals. Now, the square root of 20, if we simplify that radical, it's the square root of 4, square root of 5, so the radius is at 2 square root of 5. But we're writing the equation. So we actually really need to find that, because it's x minus negative 1 squared, y minus 2 squared equals r squared. And r squared, we saw already, was the square root of 20. So instead of writing r squared, we can just put 20. So clean that up, you get x plus 1 squared plus y minus 2 squared equals 20. And there's the equation of our circle in standard form. Number 14, the diameter of a circle has endpoints at negative 4, 1 and 4, 1. So visually, if we think about this, not drawing the scale, negative 4, negative 1, positive 4, positive 1. So like the last problem, we had a point on the circle. We actually have 2 points, but what we don't have is where the center is. Now this is a diameter, and the diameter goes from one side of the circle through the center all the way to the other side. Now this segment here, from the center to this side, is the radius, and from the center to this side is the radius, and the radius is equal all the way around the circle. So we can find the center by finding the midpoint of those 2 points. So using our midpoint formula, x1 plus x2 over 2, y1 plus y2 over 2. So it's going to be negative 4 plus 4 divided by 2, negative 1 plus 1 divided by 2. So the midpoint, 0 over 2, 0 over 2 again. So the midpoint is at 0, 0. That's our value for h and k. That's our center. We now need to find out what the length of the radius is. So we can pick either one of these points. I'm going to use the 4, 1. X minus h squared, y minus k squared equals r squared. So we have x, 4, minus 0 squared, y minus 0, that's a 1 minus 0 squared equals r squared. So we get 4 squared, which is 16. 1 squared is 1, equals r squared. So 17 equals r squared. So the radius is the square root of 17. So it's x minus 0 squared plus y minus 0 squared equals r squared, which in this case is 17. So when we clean that up, we can just write it as x squared plus y squared equals 17. And there's the equation of that circle. And number 15. The center, 3, negative 2, that's hk. And it says a solution point. That's the same as a point on the circle. So that would be our value for xy. Because once again, we don't know the radius. We need to solve for it. X minus h squared plus y minus k squared equals r squared. Negative 1 minus 3 squared plus 1 minus negative 2 squared equals r squared. Negative 4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. R squared equals 25, so the radius is 5. So we have our equation x minus negative 1 squared plus y minus 1 squared equals, and r squared was 25. So that's x plus 1 squared plus y minus 1 squared equals 25. And that's the equation of that circle. Only difference there was before it said a point on the circle. Here it said solution point, same thing. Now we're going to finish up this section by going over some important graphs to think about. These are the parent functions. It's a good reference to have. I might go through a little fast. Don't forget you can pause it and the answer key will be posted online. So a constant graph. If you see x equals a, that's a vertical line. So what that graph would look like, here's our coordinate plane. For example, there's a line of x equals a. If you see y equals b, that's a horizontal line. So a line that looks like that, there's an example of y equals b. Linear. Even though the other two are linear, if we see y equals x, 2 variables. So think about slope-intercept form. There's a line. I'm going to redo that one, actually. Because it should go through the origin. There's y equals x. Pretend that goes through the origin. For y equals x squared, our quadratic, our parabola, looks like a U. There's y equals x squared. Absolute value is shaped like a V. We'll be exploring these a little bit more in depth as we go through. that's an absolute value function. That V shape. Y equals the positive square root of x. This is a square root function. And it looks like that. A cubic. Y equals x cubed. The graph looks like that. Reciprocal function, if you remember back from Algebra 2 with the asymptotes, where keep in mind x cannot equal 0. And there's our graph. It's that hyperbola. So here's x equals 0. That's our asymptote, our vertical asymptote. And our asymptote y equals 0. It'll never cross those lines for y equals 1 over x. That is it for section 1.2. Thank you.